Hello everybody, my name is Roman Rodriguez, and as you all know we are doing chapter 3 of physics, and the chapter is all about kinematics of linear motion. Today we are in lesson 3, and first you need to know what is kinematics. Kinematics is derived from a Greek word kinema, which means motion. So here kinematics is that branch of physics which deals with the motion or of those objects or body without the influence of any force. That means we will not be discussing any internal or external force acting on a body which is in motion. So simple definition of kinematics would be it is a study of the motion of points, of objects and groups of objects without considering the causes of its motion. Now, when you talk about motion, then you also have rest in mind, and the difference between motion and rest. Well, when a body changes its position with respect to its surrounding, then we say that the body is in motion. And when a body does not change its position with respect to its surrounding, we say that the body is in rest. Now, like for example, when you talk about motion, a car is moving and you see that the trees and the buildings outside, they are all at rest because they are not moving along with the car. Okay, to compare to the surrounding, with respect to the surrounding, the trees and the buildings are at rest, but your car is in motion, is moving. But you sitting inside the car, you are at rest. But since you are moving along with the car, so relatively, if you look at it, you are in motion. Okay. In the same way, the trees and the buildings also relative to the universe, because you know that the Earth revolves around the sun. Okay. So since the Earth is revolving, so everything is in motion relative to the universe. So this is what rest and motion, we can say they are relative terms. In simple terms, an object that causes its motion is which changes its position is said to be in motion, while the opposite action causes an object to be at rest. I hope it's clear to you the difference between rest and motion. Okay, now what are the different types of motion? Well, there are many types of motion. The three types of motion that we will be discussing in this chapter here is translatory motion or linear motion. This is a motion which is moving in a straight line. Rotatory motion or circulatory motion is a motion which is moving around in a circle, rotating in other words. And vibratory or oscillatory motion is a motion which vibrates or it oscillates. I'll give you the examples. Translatory motion or linear motion. So motion when the particle of an object is moving to the same distance, same time is called translatory motion. In other words, motion in a straight line. Like for example, the motion of an aeroplane or car, okay, or a train, they move along a road, in the railway tracks you could say, okay, so ball roll on the ground, or bullet fired from a gun, a stone hurled from a catapult. They are all motion in a straight line, and we call this motion or this movement as translatory motion or linear motion. Now, rotatory motion or circular motion is all about a body which moves about a fixed axis without changing its position. Now, for example, the Ferris wheel you see that is moving in circle, and as you know, the plane moving is linear motion or translatory motion, but the propellers, they are moving around a fixed point, so they are rotating just like the ceiling fans that you have. Okay, they are rotating around the fixed point, and then you can also say the car which is moving in a straight line is translatory motion, but the wheels are rotating around, so that is an example of a circulatory motion. So example of circular motion, as you all know, is a spinning wheel, potter's wheel, or I just give you an example, and even the earth which is moving around the sun, etc. They're all example of circulatory motion. Right. And then we have the third type of motion, which is vibratory motion or oscillatory motion. Now, this is a motion which moves to and fro or back and forth, like that of a pendulum, you could say, okay, or you could look at an example of strings of the guitar, the sitar, the musical instrument that we have. When you strum it, when you pluck it, what happens? It vibrates. Okay, so this is an example of vibratory motion or oscillatory motion. So it is to and fro or back and forth motion described by an object as a whole along the same path without any change in the shape of the object is called oscillatory motion. Okay. Now, the next topic in this chapter is all about speed and the types of speed. Now, what is speed? The definition of speed in physics is the distance covered by a body in a unit time. Okay, this is a simple definition. Mathematically, we can say speed is equal to distance upon time. And the types of speed that we have: a uniform speed or constant speed, we can say variable speed, average speed, and instantaneous speed. Now, what is uniform speed? An object is said to be in uniform speed when the object covers equal distance and equal interval of time. Like for example, over here you can see that the distance of 1 kilometer is covered by this car in 1 minute. So the speed will be kilometers per minute, will be 1 kilometer per minute. Okay, distance upon time. And then you can see in the next 2 minutes, the distance covered by the car is 2 kilometers. So 2 divided by 2 would also give you 1 kilometer per minute, distance upon time. So you can see the car is moving over here with a constant speed or uniform speed of 1 minute per 1 kilometer per 1 minute. Okay, kilometers per minute. But remember, in SI unit, the speed is calculated either in kilometers per hour or minutes per meters per second. Okay, keep that in mind. Now, variable speed. Object is said to be in variable speed when an object does not cover equal distance and equal interval of time. As you can see over here in this example, that in 1 second 4 meter distance is covered. So the speed over here of this car would be 4 meters per second. But then when you look at the next moment, it covers a distance of 10 meters in 2 seconds. So the speed over here would be 5 meters per second. So from 4 meter it has now moved to 5 meters. Okay. In the previous example, you could see that the car was moving at the same constant speed, which is called uniform speed. But here the speed changes. So when the speed changes over here for every equal distance and equal interval of time, we call the speed a variable speed. Variable means change. Okay. Now, what is average speed? Now, average speed is defined as a uniform speed which is given by the ratio of total distance traveled by an object to a total time taken by the object. Now, whether it is uniform speed or variable speed, the total distance covered um, by the car upon the total time taken, when you divide the two, you get the average speed. Okay, so it's the total distance upon total time taken. Instantaneous speed. Now, simple definition of instantaneous speed would be like when a car is moving at any speed, whether it's uniform or variable, the car has a speedometer, and at that moment, at that instant, the speed of the car is called the instantaneous speed. So when an object is moving with variable speed, then the speed of that object at any instant of time is known as instantaneous speed. You can say like the variable speed that you see when the car moves, the speed changes. But then when you want to know the instantaneous speed, you will know at that moment what its speed was. So that is called instantaneous speed. Okay, then we move on to velocity and types of velocity. Well, velocity, in simple terms, it's speed in a particular direction. Is called velocity. Now, the definition of velocity in physics is the distance covered by a body in a particular direction in a unit time. So, we could say that in speed you have distance upon time. In velocity, we look at the displacement upon time. It has a direction. Okay. So, like for example, over here, speed tells you how fast you are moving, and velocity tells you speed in a given direction. Now, there are three types of velocity. That is uniform velocity, variable velocity, and average velocity. So uniform velocity, as you can see over here, is when the speed and direction of the motion of the body does not change. It's moving constantly, the uniform velocity. You can see over here, uh, when you plot a graph between velocity and time, you can see a straight line which indicates that it's somewhere between 40 and 50 um, meters per second. Okay, it's moving with a constant velocity. And here too, the distance, equal distance and equal interval of time in a particular direction, this velocity is called uniform velocity. Remember, the difference is only in direction. So speed in a particular direction is called velocity, if you want to know the difference between speed and velocity. Variable velocity, the velocity of a body changes if its speed changes or direction or both. Such velocity is called variable velocity. Just like variable speed, you have variable velocity in a particular direction. So you can see that it is moving with different interval of time, with different distance. So this is called variable velocity, the change speed in a particular direction. Right. Average velocity is defined as the total displacement traveled by an object to a total time taken. So the total distance or displacement you say divided by the total time taken will give you the average velocity. And what is instantaneous velocity? Well, the point over here you can see in the next graph. Okay, at this moment, whatever the velocity was, that particular direction, that will give you the instantaneous velocity. Okay, I hope it is clear to you all. I will be doing acceleration and the types of acceleration. So I hope you have all understood. Okay, take care and stay safe.